if that. So we basically, mowed the crop under, and that relationship of growing, beet seed or Swiss chard seed ended because of what we like to use in the organic movement, transgenic trespass. And in Europe, they don't call it genetically modified, they call it transgenic, because we've literally taken genetics from one organism and put them in another organism where that would never happen in nature. This is impossible. You can create a mule by crossing two similar species, but it's sterile. But in the case of genetically engineered or transgenic, it's possible to, for that plant to replicate itself and escape. And in my experience of working with, this lawsuit against the USDA, again, that we won, and won on 2 appeals, to only have it thrown out from Obama down on a politically motivated issue. We found in our research that they were finding beet pollen 30,000 feet in the air in airliner engines. It's a wind-pollinated crop, so it's very light. They were also finding up to 10% crossing 12 miles away. So the idea of coexistence is a non-issue. For one, my friend and colleague Frank Morton has been part of this movement for a while. He's in the Willamette Valley, has wild garden seeds, and has been a pioneer in the organic seed movement for 30 years. Has found that, so GMO sugar beet pollen can get in your beet seed field or your chard field, and as an organic seed grower, your crop becomes worthless. But for a GMO producer, a producer of GMO sugar beets, that crop can still be a viable crop. And they can sell it. The organic, pollen is not degrading the economic value of that. So, and just to back up a little bit and just explain some basic science of how this works, and I've lectured extensively about this and how to produce seed, and also a bit of how the process of the transgenic GMO seed production science works. Basically, everybody understands what a chromosome is. It's 2 strands of DNA, and the genes are lined up on that. The process through which a gene from one organism is inserted into that chromosome, that DNA strand, is basically completely arbitrary. And this is based on studying with my friend John Navazio, who is a PhD plant breeder from the University of Wisconsin, and is internationally recognized as one of the experts on organic seed production and plant breeding in an organic context. So basically, they're using a virus, and in this instance, they're using what's called black rot, or xanthomonas. It's a virus that affects the crucifer family, the brassicas, cauliflower and stuff, to degrade the gene linkages between the individual. Imagine the DNA is like marbles on a string. To degrade those bonds, and then they use particleized gold, and the foreign DNA is blasted in there. Literally, the common name for the tool that's used is called a gene gun. So first, they're inserting a virus from one organism that would never get in that plant. So we're introducing a potentially human health issue there. And then we're using particleized gold to degrade that bond, to insert this gene that sometimes will work, and that's how they then go on to create a new GMO crop. So one thing about genetics that we are learning through the largely unregulated release of GMO crops into the environment, was at a time?
3 minutes.
Thank you. Is that these gene linkages between these individual DNA marbles, if you will, to use that metaphor, actually confer traits. So in humans, everybody's heard of sickle cell anemia. It's a pathological thing that can affect us where you're not healthy anymore. That is not conferred to a single gene on this strand. That is the result of a gene linkage. So when you separate those, all of a sudden we lose our resistance to sickle cell anemia. Again, albinism. The gene linkage that confers for albinism is another one that is broken. So for instance, we're just blasting this thing in there. We have no idea where it's actually going to lodge into the DNA strand. And now with over a decade of GMO crops out in the open environment, we're beginning to see some repercussions. So for instance, everybody knows the corn-soy rotation that's prevalent throughout the Midwest. You got corn, which is a grass, heavy feeder, requires a lot of fertility, in particular nitrogen from the soil. And then you have soy, a leguminous crop. and it fixes nitrogen from the atmosphere into the soil and helps maintain somewhat of a balance. So farmers alternate 1 year of corn, another year of soy, and you maintain some semblance of soil fertility. Well, in GMO soybeans, we're just finding this out right now, they don't fix nitrogen. We totally screwed up that whole rotation, the building block upon which a significant portion of the American food supply is based upon. So now farmers are seeing their yields plummet in these areas. They go to the seed shelves at their farm store suppliers, and they don't got a lot of choices, because you think about it, 90% of the soy genetics out there, the varieties of seeds, are GMO. They're completely monopolized by Monsanto, and I'm not sure if Syngenta produces soy or not, but anyhow, there aren't any choices. So they can't say, oh, gosh, that GMO one didn't work, I'm going to go try something else. It's just not there. For one, not only is it not an option, we've so put our eggs in the basket of GMO that we don't have the production capability. There isn't the sacks of seed on the shelves if farmers were to want to make that choice. So, likewise with sugar beets, we're doing the whole same thing. We're putting all, and I'm just using this as the American populace because we are a democracy, right? Yes. Or I thought we were. Have put all our eggs in that basket. So we've gone from 0% GMO sugar beets to 90% in a matter of 95 in 2 years. So the table sugar on your table, 60% of that table sugar is now GMO sugar beet based. Okay, so this is something I think that's really important to consider. And we're seeing more of these problems like the GMO soy that doesn't fix nitrogen. They're also finding it has lost its heat tolerance, and in excessive heat waves, the yields are plummeting. And farmers are going bankrupt and just giving up because it's not worth it. Their margins are so narrow. So what we want to do with this movement, and I appreciate Chris Hardy and what the GMO-free Jackson County is doing, is to avert these threats. This isn't just about me and my own little family farm seed business, although I obviously have a vested interest in that, and have lost significant economic opportunities to produce seed. For instance, the rainbow Swiss chard that I've developed my own variety, has risen to the top in 4 different land-grant university trials. University of Wisconsin, University of Washington, also out of Cornell and at OSU as the best variety. So now my opportunity to produce that is severely limited because it is a crop that would cross with GMO sugar beets. If not, we could be growing 1,000 pounds of this stuff at a super high value over with Steve Fry and be putting Jackson County and organic farming on the map of a significant contribution to local, organic, bioregionally adapted food, where we also have the seed supply.
Thank you very much for your presentation.
Yeah, you're welcome.